I hate this. Everything. I just want to be done. Alright, I clicked on the wrong thing. I'm gonna click on. Oh, this? La 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 la. Fuck, wouldn't it be in here? I'm gonna piss my pants. Piss my pants. I'm gonna piss. I'm gonna piss. I'm gonna piss my pants. I'm gonna piss my pants. I'm gonna piss my pants. I'm gonna piss. I'm gonna piss. I'm gonna piss my pants. I'm gonna piss. Oh, I finished my coffee. I'm gonna piss. I'm gonna piss. You don't like my song? Why don't you like my song? Why? Why? Babe's like, I'm not talking to you anymore. He's leaving me! He's leaving me because he doesn't like my song. Why, baby, why? Ugh. I'm just trying to find a literature paper that talks about the molecular weight of Tem-1. Because, like... Meow. Meow, 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 meow. Meow, meow, meow. I'm going to call it. Oh shit, yeah. The last 4 assignments. The hell? This is due. Oh, that's Friday. That's fine. Why am I taking a quiz? I didn't even watch the lecture. What are you doing? Okay, let me pee. Hold on, Lexi just blew me up asking me how the heck she just does not know what to do for the results section for 9 and 10. She's like, it just doesn't seem like the amount of text required to explain anything is the same. Like, and it didn't for me either. I had to ask Claude. I'm like, Claude, I don't know how to like fill in space, like help. And Claude like gave me questions to answer, and or I mean, you don't really answer questions in results, but I don't know how I did that. I think I just like observed a lot. Actually, Claude didn't give me anything. I did this. Did I do this? I don't remember when I finished this. Never mind. Hold on. I have another hour before I can use Claude again. Should I just like make a new conversation then and see what happens? Because I can just be like, hey, can you edit this? It's the discussion part of a report, and I can't have any results or methods, just discussing the things and like have it just edit that way. Yeah.
So LinkedIn has responded to the whole scandal of them spying on everybody's browsers, and they said there's a house of cards built entirely on a fabrication. Yeah, I don't believe that for a second. So yeah, LinkedIn is basically saying that the whole browser extension scanning thing that they've been exposed for is not true. So they're actually getting hit with 2 class action lawsuits right now over the browser extension scanning. So if you guys don't know what I'm talking about, I made a video about 9 days ago talking about the fact that LinkedIn has been caught basically scanning your browsers and actually having data breaches happen because LinkedIn was actually looking at sensitive data on your browsers and harvesting it and actually sending it to, quote, trusted third parties. And so what they were doing is while you're on LinkedIn and while you're over there trying to get a job or network in your community or whatever, they were going ahead and planting some stuff in your browser where they were actually watching everything that you do. They know each user's real name, employer, and job title because that is the information that you give them when you sign up for the website. But they actually knew a lot more than that, and they were actually able to find out a lot about you through your browser. An organization called Fair Linked actually exposed LinkedIn for actually going ahead and snooping on your browser, and they actually did a ton of research behind LinkedIn and found massive breaches of personal data. LinkedIn scan was revealing things like your religious beliefs, political opinions, disabilities, job search activity of identified individuals, just a bunch of information about you that you did not give them willingly at all. And nowhere in their privacy policy did they say that they would be doing that or why they would even need to do that. I mean, it was just a crazy situation.
Okay,
Who's
who's that guy? I feel like I've heard that name before, but
so 2 class action lawsuits have been filed against LinkedIn because of that whole BrowserGate thing. However,
yeah.
LinkedIn says the dispute is overblown and mischaracterizes practices already disclosed in its privacy policy. I do not trust LinkedIn at all, and I will explain why later. But to look at
Okay,
what they
no,
said,
I have no idea.
push up their glasses and sound smart, they basically said, this is a house of cards built entirely upon a fabrication. We do disclose that we scan for browser extensions in our privacy policy in order to detect abuse and provide defense for site stability. So the lawsuits were filed on Monday in a U.S. District Court in California after a German group, Fairlink, published a report about the Chrome browser extension scanning, which occurs via a JavaScript
Wow.
on the LinkedIn site. The report found that LinkedIn
Fuck
willingly
around and
carried this
find
out
out.
beginning in 2022 and claims the company can harness the data to profile users and see whether they're using competitor software. However, LinkedIn says the browser extension scanning is intended to stamp out web scraping. We do not use this data to infer sensitive information about members. And they actually went ahead and provided this screenshot over here where they said, we also get information about your network and device, web browser, and add-ons. And they go ahead and say that. But that doesn't actually make any sense because they make it seem like they just get some information about your web browser, like, you know, cookie IDs and all that crap. Like not sensitive information, like, oh, it's not that big of a deal. We're just using it to stop web scraping or whatever they call it. But they were actually getting very sensitive information about their users, and they have been exposed for doing so. So they're trying to go ahead and cop out. And as you guys have heard me repeatedly say, I don't trust LinkedIn at all. And the reason is because they've also been exposed recently for working with Persona to go ahead and scan your face, facial geometry, IP address, and all that type of stuff, and send it to all these, you know, global network of trusted third-party data sources. They're using Persona Identities, an ID age verification company that we have talked about many times. Me and their CEO actually got into it, and he is still yet to reply to my detailed response to him where I outlined every single scandal that his company
All
is
right,
involved in.
maybe.
But that's a topic for a different day. But basically, in a 3-minute
Do
identity
you want to watch me
verification,
lecture with me or no?
you will get your
Maybe I should start my laundry. Should I start my laundry? Yeah. Yeah. I'll be right back.
full name, passport, selfie, facial geometry, national ID number, nationality, sex. They probably have your grandma's middle name as well. This is something we've talked about before. They were getting a ton of information about you, and they were exposed and essentially proven to be sending all that information out to all these, you know, quote, trusted third-party sources. Government databases, national ID registries, consumer credit agencies, utility companies, you guys get the idea. They were sending your information to everything. And as usual with pretty much all of these ID age verification companies that are going ahead and scanning all your information because they claim that they're trying to protect the kids, they are using your information to train their AI, to train their AI models to make AI as realistic as possible. And that's why LinkedIn and Persona, by extension, were scanning for your freaking facial geometry, dude. Are you kidding me? It's not Persona that was just doing it. LinkedIn was also receiving your full name, birth year, government ID, verification result, and a blurred version of your identity. They were getting a ton of information about you too. And now they're over here saying, oh, we were just doing it to stop web scraping. Yeah, get out of here, man. I don't believe a single word that they say. LinkedIn frames the extension scanning as a privacy safeguard since it can stop the scraping of LinkedIn member pages without user consent. But despite the justification, the class action lawsuits demand that the Microsoft-owned site pay damages to affected users and cease browser extension scanning, arguing that LinkedIn went too far. Totally agree. No reasonable user would read generalized extension scanning, arguing that LinkedIn went too far. Totally agree. No reasonable user would read generalized references to URLs, browser data, add-ons, device features, cookies, automated system security, anti-abuse, fraud prevention, or similar matters and understand that LinkedIn would covertly interrogate the user's browser, enumerate or infer installed extensions, one of the complaints says. One class action lawsuit from California resident Jeff Gannon argues that the browser scanning violates the Electronic Communications Privacy Act and the California Comprehensive Computer Data Access and Fraud Act, as well as other state laws. The second lawsuit from another resident named Nicholas Farrell invokes similar claims but focuses more on how LinkedIn's alleged conduct violates California laws. LinkedIn claims that the dispute stems from Teamfluence attempting to web scrape data. The German group Fairlink says it represents commercial LinkedIn users. One of its board members is listed as S. Morel, who appears to be Stephen Morel, the founder of Teamfluence, a tool that helps businesses monitor LinkedIn activity. LinkedIn claims that the dispute stems from Teamfluence attempting to web scrape data, prompting the social networking site to crack down. So we acted to restrict the accounts associated with Teamfluence. In retaliation for their accounts being suspended in January, the creator of Teamfluence sought an injunction against LinkedIn in Germany, according to LinkedIn's VP for Legal, Sarah White. I'm happy to report that the court thoroughly rejected Teamfluence's claims, reaffirming LinkedIn's ability to act swiftly and decisively against bad actors who access member data inappropriately. So this is turning into a bunch of he said, she said shit. In a statement to PC Mag on Monday, LinkedIn also said, unfortunately, this is a case of an individual who lost in the court of law but is seeking to relitigate in the court of public opinion without regard for accuracy, alluding to the browser extension scanning. However, Fairlink claims the court case Microsoft cites has nothing to do with the surveillance operation. That case concerns an account suspension. Browsergate was never mentioned in the proceedings. Microsoft implies it prevailed. It did not. A motion for a preliminary injunction was denied. Both plaintiffs have appealed. The litigation is ongoing. The group also questions LinkedIn's justification for the browser extension searches. Scanning for 6,000 extensions and transmitting the results to third parties without user consent is not server protection. It is an illegal spying operation, it says. The scan list contains thousands of extensions that have nothing to do with scraping, religious extensions, political opinion extensions, job search tools, neurodivergent ads, Amazon image downloaders, pharmacy operations tools, delivery schedulers. Clearly, server protection is not the goal here. Shout out to Michael and PC Mag for writing this article, but yeah, this actually seems like a really good argument from Fairlink. I don't trust a single word that LinkedIn says purely because of their partnership with Persona. Again, and I said this to my video that I made about Persona and their CEO Rick Song, if Persona was exposed like once and he had some sort of explanation and evidence to suggest that that Persona was actually not in the wrong, I would actually give them the benefit of the doubt. But Persona has been exposed by like 4 or 5 different sources that are claiming that Persona has faulty security. And over here, LinkedIn is working with them to go ahead and send all these companies your freaking information. Anthropic, OpenAI, Grok Cloud, AWS, Google Cloud Platform, you get the idea. These guys are all getting a hand in your information just because you did one little scan on LinkedIn to try to get your profile verified so you have a better chance of getting a job. All of these companies, especially like the big ones, man, these guys are vultures. They don't give a crap about you or your individuality.
This brand new telescope just sent scientists 800,000 alerts in one night, each one flagging that something has changed in our sky. This telescope contains the largest camera in the world, and every night it's been capturing new images of the sky. So over time, it combined them to understand how each patch of sky typically looks, creating template images. So then when new images are taken, it can subtract the template image pixel by pixel to see if there are any changes. And it caught all of these supernovas, stars exploding as they collapse and die, and all of these black holes devouring matter at the center of galaxies, spewing light and energy into the universe, and these totally new objects, likely asteroids that we've never seen before. And that's just some of the 800,000 alerts it sent out. And eventually the telescope is expected to detect up to 7 million changes per
Hi, I'm François, the developer. So I made Starship Evo because I wanted to recreate a very specific fantasy. Being the captain of your own starship. Exploring the galaxy. Not just flying your ship, but being inside it. Walking through its corridor, living in it alongside your crew. The sci-fi in Starship Evo is really over the top. You will visit Stargate, massive space habitat, space station, meet and hire funky looking aliens. We even have merging beams, so yeah, you get the idea. I crafted a living galaxy that you can explore with entire faction that you can fight in the core and arm, or pirates roaming the outer rim. Of course, you can land on planets, mine asteroids in planetary rings or refuel nearby stars. As a kid I was into LEGO space, so being able to build a functional ship, walk to the pilot seat, take control, lift off, and just fly into space, it really feels kind of magical. The building system gives you maximum freedom. You can stretch blocks to get the exact shape you need. Need a 3-to-1 corner to match your wedge? Just stretch it and make it appear. It really feels natural and empowering. Once you try it, there is no way back. There is no prefab that tells you how a cockpit should look like. You get to design everything the exact way you want. Have some crazy idea for a seat mechanism? Yeah, you can build it. The survival update finally ties everything together. You will need to harvest resources to craft bricks and then work on your ship. You will have to manage power, fuel and oxygen levels. And you will visit space station where you will tackle mission, do some bounty hunting or trade valuable cargo. And with the cash earned you will hire crew members that will join you on your ship. You will need to sweat quite a bit to build a ship big enough to defeat a faction fortress. But
Alright. Hello. Bringing laundry to the laundromat. I had to do my blankets and the bathroom mats, and I had a load of clothes. I can only fill up my laundry basket so much. So I came back to strip my bed and get the bath mats. There was a guy in there, and I was like, did the price of this go up? And he goes, yeah, the washing machines went up a quarter. I'm like, okay, because I'm like, I don't remember it being $225. And he's like, yeah, he's like, they're probably going to keep going up, honestly. And I'm like, yeah, it wouldn't surprise me. He's like, but we have a laundromat on the street, so they probably won't go up that high. And I'm like, how high is the price on those? He's like, $325. I'm like, Jesus Christ. Like, for fucking laundry. And he's like, yeah. He's like, honestly, he's like, next place, totally wanting a house with a fucking, washer and dryer. And I'm like, yeah, I keep saying it's like my next place, definitely gonna have an in unit, 'cause fuck this. And he goes like, honestly, he's like, you can get a house around here, or a room in a house with a yard and everything with an in unit for like $1,200, $1,300. So it's like $100 more than here. It's like, I don't know. He's like, it sounds like the better way to go, to the way the prices of these apartments are going up. It's just not fucking worth it. I'm like, yeah, I've been thinking about it. But then again, my situation, like, I don't want to be here forever. I don't want to move again. I want my next move to be a new state, like up north. Like, I don't want to move again. So, but I have a feeling my rent's going to go up again. I just don't know how much they're going to make it go up. But we'll see. Mm-hmm. My internet bill went down $30. I just got it. It significantly went down, so I was like, okay, that's cool. Yeah. Anyways, I have like 5 loads of laundry going, and I think I have like about 20 minutes on the first load, so start this video. Oh, I need my notebook. I can't do shit without my notebook. I don't have room in my notebook. Where am I going to take notes? I don't have any more paper. I have some room left. I probably have enough left for this lecture, and then I need to get a new notebook. I meant to do that today too, but I've just been too absorbed. Okay.
Welcome back. Up to this point, we've been plotting points and curves in the plane using what we call the Cartesian coordinate system, where we describe our points using an x-coordinate and a y-coordinate. The x-coordinate gives us the sign distance to the y-axis, and the y-coordinate gives us the sign distance to the x-axis. And this coordinate system is sometimes called a rectangular coordinate system because if I were to take a point and project it to my axis, it's going to look like a rectangle. And this rectangular coordinate system is particularly useful in terms of describing lines. But there are a lot of curves that are difficult to describe in terms of Cartesian coordinates, even simple things like circles. So in this lecture, we're going to learn about another coordinate system, the polar coordinate system, where we'll be able to describe points in terms of circles. Let's consider a point in the plane. Rather than describing it in terms of its x and y coordinates, we're going to describe it in terms of 2 variables r and theta. The r is going to represent a signed distance from this point to the origin, and the theta is going to represent the angle that we're making with our positive x-axis. So for example, if I were to go ahead and just plot out my axes, if I have a point here that would be in our first quadrant, if I connect this point down to the origin, my r will be the length of that line segment, and my theta is going to be equal to this angle we're making with this positive x-axis. And so in this way, given a value of r and a value for theta, we can describe any point that we have in the plane. And so let's use this idea to take some polar points and then try to plot these in our plane. So we have 4 points here. These are going to be polar points. And when we're describing these polar points, this first coordinate here is going to be my value for the r, and the second coordinate is my value for the theta. So for each of these points, I'm thinking about how far am I going to be from the origin and what angle I'm making with the positive x-axis. And so normally we would deal with the angle first, because if I were to talk about this angle of pi/3 radians we're making with the x-axis, we're talking about this ray that's coming out of the origin, going through this first quadrant. And so when I'm moving along this ray, we're talking about all those points that would have this angle of that pi/3 with the positive x-axis, and then it's just an issue of making sure that we're choosing a point that's going to be 3 units away from the origin. So when we're moving along this ray, each of these concentric circles is going to be 1 unit from the origin. So I go out to that third circle, I have a point right here. This is going to be our point A. So it's a distance of 3 units from the origin, and it's making that angle of the pi/3 radians with our positive x-axis. For our second point B, we are going to be 1 unit away from the origin, and we're making an angle of 5pi/2 radians with that axis. Now remember that there are a total of 2 pi radians in our circle, and so if I'm starting on my positive x-axis, I'm sweeping all the way through to get back to where I started. That's going to be 2 pi radians, and then have an additional pi/2 I need to go to get to this angle. And so that's going to be on our positive y-axis. We're then going to have this point up here. We'll call that B. And what I want you to notice is that in terms of plotting this point, rather than describing this point with the value for r being equal to 1 and the value of theta being equal to a 5pi/2, we just as easily could have described this with our value for r being a 1 and our value for our theta just being a pi/2. Notice that in general, there's not going to be a unique way to represent these points in our plane. Now, we're usually going to try to restrict ourselves to having angles between a 0 and a 2 pi, and then the corresponding value for r. But there could be lots of ways in which we could describe a point. For our third point, we had this value for r as a -2, and then my value for the theta is going to be a pi/4. So the value for this theta gives me the fact that we're on this 45-degree angle line coming out from the origin. And normally I would have my value for r then kind of falling on this ray here if we're positive. But the fact that this value for r is negative, so we call assigned distance, is going 2 units in the opposite direction. So if we think about this entire line, this would be the line of y is equal to x in the plane. The fact that we have this angle that's in the first quadrant, but the negative value for r is actually pushing us into the third quadrant. And so we're in the third quadrant, we're 2 units away from the origin on that ray coming out, going through that third quadrant. So this point right here is going to be our point C. Notice if we wanted to, we could just as easily have described this with a value for r being equal to 2. And if I had done this, the angle I'd be making with the positive x-axis would then be equal to a 5pi/4. All other things being equal, we would like to be able to describe our values for r with positive numbers, but there are going to be some situations where we are going to have to deal with negative values for r, so we need to make sure we know how to kind of deal with this. That negative value for r, I'm going to look at whatever my theta is, but I'm just going to push through into the opposite quadrant. And then finally, for my last point, my value for r is equal to 0, my angle of my theta is equal to a pi. Well, the fact that r is equal to 0 means I'm going to be 0 units away from the origin, which means that I am just going to be here at the origin. And notice that we just as easily could have described this with that value for r being equal to 0, and I actually could have used any value for theta, so it doesn't matter what angle I'm trying to make with that positive x-axis, because we're not actually going to be able to make that angle because we're not moving away from our origin. So we'd like to be able to convert between our polar coordinates and our Cartesian coordinates. And so if we have a point here, for simplicity, we're just going to have this in the first quadrant. I could think about this point as being the point xy, using my Cartesian coordinates. I can think about this as being a point r theta using my polar coordinates. I would like to come up with some equations that are going to relate these values of x and y to the values of r and theta. So that way, if I'm given polar points, I can turn them into Cartesian points. Or if I'm given Cartesian points, I can then turn those into polar points. So we're going to do a little bit of trigonometry with this triangle here. Notice that when I have this point xy, when I'm projecting down toward the x-axis, we're making this right angle down there. So we do have a right triangle. And I know then that I can look at the sine and the cosine of this angle theta to be able to represent the values of x and y in terms of that hypotenuse r. So for example, if I were to look at the cosine of this angle theta, well, I know for my SOHCAHTOA we have the ka. The cosine is going to be the adjacent side divided by the hypotenuse. So this is going to be equal to an x and then divided through by an r. If I were to then go ahead and multiply both sides of this equation by an r, I would have that my x is going to be equal to r times the cosine of theta. So from this equation, if I happen to have a value for r and a value for theta, I can just plug into that r times cosine of theta. That's going to spit out the value for the x-coordinate for that point. Similarly, if we look at the sine of this angle theta, remember that in our SOHCAHTOA, this is the SO part. Our sine is going to be the opposite side divided by our hypotenuse. And so that's going to be the y, then divided by the r. Once again, if I go ahead and multiply both sides by the r, we're going to end up with y is equal to r times theta. And so these two equations right here are going to allow us to take polar points and then convert them into Cartesian points. We also come up with some equations that will allow us to determine the values for r and theta in terms of the x and the y, because with this triangle, I can use my Pythagorean theorem. For my Pythagorean theorem, I know that if I take the hypotenuse and square that, that's my r squared, it would be equal to an x squared and then plus y squared. So in this way, given an x coordinate and a y coordinate, I can then solve for the r coordinate, my polar coordinates. And then similarly, using some trigonometry, I can come up with an expression for my angle theta in terms of the x and the y. Now remember, the TOA in our SOHCAHTOA says the tangent is the opposite over the adjacent. And so if I wanted to calculate the tangent of our angle theta, this would then just be equal to the y divided by the x. As we have these two equations down here, that will allow us, given values of x and y, to find our values for r and theta. And notice that with this last equation here, if I were to take the arctangent of both sides, we would find that our theta would be equal to the arctangent of the y divided by x. So we can use these equations here to allow us to convert back and forth between polar and Cartesian points. So as an example, let's go ahead and convert some polar points to Cartesian points. And so we're going to be dealing with the same 4 points that we had at the beginning of the lecture that we plotted in our plane using those polar coordinates. Now remember, the equation I'm going to be using here, because I'm taking the polar and trying to convert this into Cartesian, I'm going to use the equation of x is equal to r times the cosine of theta, as well as y is going to be equal to r times the sine of theta. So given a value for the r and the theta, I can find my x and my y. So for example, with this point A, I have a value for r is equal to 3, and a value for theta is equal to a pi over 3. My x-coordinate would be equal to this value for the r, which is a 3, and then times the cosine of the pi over 3. Remember that a cosine of pi over 3 is going to be equal to a 1/2, so I'm going to end up with a 3 divided by 2. And then my value for the y is going to be equal to my r, which was a 3, and then times the sine of the pi over 3. Well, the sine of pi over 3 is going to be the square root of 3 over 2, so I'll end up with 3 times the square root of 3 divided by 2. So then as a Cartesian point, we would have the x-coordinate of 3/2, and then my y-coordinate would be equal to 3 times the square root of 3, and then divided by 2. And if we were to go back and look at the point that we had plotted in our plane using these polar coordinates, we can see that these x and y coordinates are matching up. Notice that this picture I have right here, I have my point A. If I were to go ahead and look down to find that x-coordinate, notice that it's going to be about equal to the 3/2. And then if I go over and find the y, we're going to get that value that's going to be a little bit less than a 3. That's going to be equal to that 3 times square root of 3 divided by 2. So it's kind of matching up with that point that we had plotted using the values of the r and the theta. For our second point, let's go ahead and plug into our formulas. So my value for x, remember, is going to be r times the cosine of my angle theta. So that's going to be a 1 and then times the cosine of the 5 pi divided by 2. Well, because with that 5 pi over 2, if I take the cosine, I just get a value for 0. That's going to give me a 0 right there. That's going to indicate that this point is going to be falling on my y-axis, which remember was in fact the case. And then for my value for y, we're going to take a 1 and then times the sine of the 5 pi over 2. Well, the sine of 5 pi over 2 is the same as the sine of pi over 2. So that's just a 1. So 1 times 1 gives us a 1. So then as a Cartesian point, we have the point 0, 1. For my third point C, we have this negative value for r. So my x is going to be equal to a negative 2, and then times the cosine of my pi over 4. Remember that the cosine of pi over 4 is the square root of 2 over 2. So when I multiply that by a negative 2, I'll get a negative square root of 2. And then the exact same thing is happening for my y. I have my value for r, the negative 2, times the sine of the pi over 4, which is also the square root of 2 over 2. So we get a negative square root of 2. So then we have this point in Cartesian coordinates where both the x and y coordinates are equal to the negative square root of 2. And this is consistent with the fact that when we plotted that point, it was falling in the third quadrant. And then finally, for this last point, D, we can look at the value for r being equal to 0 and my value for the theta being equal to pi. So my x is going to be equal to a 0 and then times the cosine of pi. Well, I don't even need to know what the cosine of pi is to know that this is going to give me a 0. And then similarly, when I look at my y, it's going to be equal to the 0 times the sine of this angle pi, which is also going to give me 0. And so this polar point is just representing our origin. So using these two equations, x is equal to r times the cosine of theta, and y is equal to r times the sine of theta, we can then take these polar points and then turn them into Cartesian points. Now, for example 3, we're going to go in the opposite direction. We're going to be given the Cartesian points. We want to find the polar points. And so in this situation, we're going to be using the formulas of r squared is equal to x squared plus y squared. And then my tangent of theta is equal to y divided by x. So given this first point, the point 1, 1, I need to figure out if my x is a 1 and my y is a 1, what are the values of r and theta? Well, notice that my r squared in general is equal to an x squared plus a y squared. So that's going to be a 1 squared and then plus 1 squared. That's going to give me a 2. Taking the square root is going to give me that my value for r is equal to the square root of 2. And then for my angle, we're going to notice then that the tangent of the angle theta will be equal to 1 divided by 1, which of course is equal to 1. And I know that if I'm trying to take the tangent of an angle and I get a 1, that means that my sine and cosine were the same. Our value for the theta then is going to be equal to pi over 4. Which means then that as a polar point, my r is equal to the square root of 2, and then my value for the theta is going to be equal to a pi over 4. For our second point, our x coordinate is a 3 and our y coordinate is a 0. So my r squared is going to be equal to a 3 squared and then plus a 0 squared. That's going to give me a 9. If I go ahead and take the square root, I'll find that my r is equal to 3. Notice that when I'm taking my square root here, I could have just as easily chosen a negative 3. And that'd be perfectly fine, but then I'd be more careful about that angle theta that I'm picking to make sure I'm kind of pushing through into the opposite quadrant. So when I'm trying to do this conversion here, I prefer to have my value for r be positive because it's going to make it easier for me to find that value for theta. Notice then that my tangent of theta is going to be the y coordinate divided by the x coordinate. So that's a 0 divided by a 3, which is equal to 0, which then means my value for the theta is going to be equal to 0. If I had chosen my value for r to be the negative 3, then because I'll be pushing through in kind of the opposite direction, I need my theta to be equal to a pi. And so it's easier to use that positive value for the r. And so we're going to have this point, my r is equal to the 3, my theta is equal to a 0. So notice that when I convert this point into the polar coordinates, I actually have the same first coordinate and the same second coordinate, but notice that these are representing two different things. In particular, that second coordinate of 0 with the Cartesian point says I'm not moving up away from my x-axis, whereas the 0 and the polar point says that we're not making an angle larger than 0 with that axis. For my third point down here, I have an x that's a -1, and my value for the y is going to be the square root of 3. So once again, my r squared is going to be a -1 squared, and then plus the square root of 3 squared. That's going to give us a 4, which then means that my value for r is going to be equal to 2. And then for my angle, we're going to have the tangent of theta is equal to the y-coordinate, which was the square root of 3, and then divided through by the x-coordinate of the -1. That's the negative square root of 3. So we want to be a little careful when we are trying to figure this out. We're trying to find this value for theta. Notice that the point that I have here has a negative x-coordinate but a positive y-coordinate. That means that this point is going to be in the second quadrant. And so because I'm choosing this positive value for r, that means that when I'm picking my theta, it needs to be between pi/2 and pi radians. So if you don't know what the arctangent of the negative square root of 3 is, and I wouldn't blame you if you didn't memorize that, remember my trick is just to write this as a negative square root of 3 divided by 2, and then divide this through by a 1/2. And in fact, what might even be better is I'll put the negative in my denominator to remind myself that was corresponding to my x's, because remember that my tangent is the sine of theta divided by the cosine of theta. And so we're thinking about an angle then that's going to be in the second quadrant, where if I take the sine of the angle, it's going to give me the square root of 3/2. But if I take the cosine, it's going to be a negative 1/2. So that means I'm looking at an angle that, as a reference angle, would be a pi/3. So I'm going to subtract that from my pi to get a value for 2 pi/3. So this tells me then that my value for theta is a 2 pi/3. Notice that this point is in fact going to be then in the second quadrant because my value for theta is between the pi/2 and the pi. Listen, as a point, our r coordinate is a 2. My theta coordinate then is going to be a 2 pi divided by 3. And then finally, for our last point, we're looking at the origin. My r squared is going to be equal to a 0 squared, and then plus a 0 squared, which is just equal to 0. So that gives me that my value for r is equal to 0. And remember, we already mentioned that because this value for r is equal to 0, I'm not moving away from the origin. And as a result, it doesn't matter what angle I'm going to choose. So we'll just say that theta can be any angle. And so we can just go ahead and choose an angle of 0. And so then using these formulas, we can convert back and forth between Cartesian points and polar points.
I'm gonna go get shift stuff over in the laundry room. I'll be right back. I have to go back. Why don't you stay here? Because I feel like those kids are taking orders. Move. That's fine. Not more. I hate